Okay, 10.5. Now we're going to talk about more angle relationships in circles. And remember, again, I'm going to stress the importance of where the vertex of the angle is in reference to the circle. Last time we talked about inscribed angles whose vertex is on the circle, and the measure of that angle is half of the arc. So we're going to have another example here, this first one, of angles that are also on the circle. These angles are just a little bit different because they are formed by a tangent and a chord. And so, but the vertex is still going to be on the circle, so the same kind of relationship applies. So if a tangent and a chord intersect at one point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. So again, we have a tangent and it's a line. So remember, a line is 180 degrees. So think about that. If a line is 180 degrees, then it's touching that circle in one spot. A circle is 360 degrees. Well, 360 divided by 2 is 180. So that's kind of how that all comes into play. Now, when you have the chord coming through here and touching the tangent, you can see that two angles are formed there. You have angle here, angle 1 is here, and then angle 2 is this whole thing. Now, when you're talking about the angles, you really just have to pay attention to the tangent and the chord, and you kind of have to just look at the circle in the background. So angle 2 is all the way from the chord to the tangent. So that whole entire thing is the angle. All right, so to find the measure of angle 1, it's going to be half of this intercepted arc. And it kind of looks like the arc doesn't touch A, but it does go all the way to A. So the measure of angle 1 would just be half the measure of arc AB. Now, to find the measure of angle 2, remember it's intercepted arc, so if here's angle 2, the intercepted arc is the arc in between the angle, so that's all of that. So the measure of angle 2 is going to be half the measure of arc, and this is BCA. So remember, this is a major arc, so we have to name it with 3 letters. So the measure of angle 1 is half the measure of its arc, and the same thing with 2. So let's see if we can use that. Example 1, it's telling you that line M is tangent to the circle. Find the indicated measure. So they would like us to find the measure of angle 1. So here's 1. If I outline it there, and I say, all right, well, its intercepted arc, here's the intercepted arc, is 132. And I know if the vertex is on the circle that the angle is half of the arc. So 132 divided by 2 gives you 66 degrees. In example B, they want us to find the measure of arc EFD. So that's this arc here, EFD. Well, if we look and say, okay, well, it is in between this angle here. Well, that whole entire angle is 110 degrees. Well, the arc is bigger than the angle. So if this is the measure of the angle, you're going to multiply that by 2 to get the measure of your arc. Now we talk about angles that are inside of the circle. So you calculate the measure of these angles just a little bit differently, but we have 2 chords. If 2 chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the 2 of the arcs intercepted by the angle and its vertical angle. So let's kind of break that down. What does that mean? All right, so this angle right here, number 1, this angle in here. You can find the measure of that angle by taking half of the sum of the intercepted arcs. So the intercepted arc is for this angle is there in CD, and also number 1 has a vertical angle over here, and you're going to also use that intercepted arc. So that's where it says that the measure of each angle is half the sum of the measures of the arcs intercepted by the angle. So this is the arc intercepted by this angle, and the arc intercepted by its vertical angle. So to find the measure of angle 1, you would take 1/2 of the measure of arc CD and AB. So you would add together arc AB, arc CD, and then divide it by 2. Now to find the measure of angle 2, you're going to do just about the same thing, but you're going to use the other arc. So here's angle 2. Its intercepted arc there is CB, so you're going to take 1/2 the measure of arc CB, and then its vertical angle to number 2 is over there. Its intercepted arc here is AD. So those are angles inside of the circle. Now let's talk about angles outside of the circle. So if they're inside, you're going to add and divide by 2. So you can think about, oh, well, if they're on the outside, what do you think you're going to do? So if a tangent and a secant, or 2 tangents or 2 secants. So this is a secant. See how it intersects the circle in 2 spots. So if you have a secant and a tangent, if you have 2 tangents, or if you have 2 secants, it doesn't matter. Remember, what matters is where the vertex is. So basically, if the vertex is outside of the circle, all right, so if they intersect outside a circle, then the measure of the angle formed is half the difference of the measures of the intersected arc. So again, you're going to take half of the difference. So here, remember, difference is you're going to subtract. So inside the circle, you add and divide by 2. Outside of the circle, we're going to subtract and divide by 2. So to find the measure of angle 1 that's formed by the secant and the tangent outside of the circle, we're going to take 1/2 and we're going to subtract. We're going to first start with the larger arc. So this is going to be the measure of arc CB, and we're going to subtract out the other intercepted arc, AC. So here, to find the measure of angle 2, again, you're looking at the intercepted arcs, so we're going to take 1/2. The vertex is outside the circle, so we're going to have to subtract. So this intercepted arc is P to Q to R. So always start with the larger arc so you don't end up with a negative number. And we're going to subtract the measure of the smaller intercepted arc. There you go, and divide by 2. The measure of angle 3, the vertex is outside. Intercepted arcs, there's XY. So again, 1/2. The smaller intercepted arc is WZ. So let's see, we have an example 2, find the value of x. It's all about where the vertex is. I cannot stress to you that enough, and you're going to have to know the difference. All right, you're going to need to know and memorize these things. If the vertex is on the circle, all right, then it's half of the measure of the arcs. If it is inside the circle, it's the sum of the arcs divided by 2. All right, if it is outside the circle, it's the difference of the arcs divided by 2. So have all those straight. So let's practice an example 2. X is sitting inside of that angle right there. The vertex of that angle is inside the circle. So if it's inside the circle, that means I have to add the intercepted arcs. So this is 1 arc. If I add it to the measure of the other intercepted arc, which is 140, I'm going to get 252, and I have to divide that by 2. So the measure of that angle where X is 126. Perfect. Let's look at example 3. Find the value of x. Well, x is sitting in an angle that is outside of the circle. Well, if it's outside the circle, I take the measure of the larger arc. I subtract out the measure of the smaller arc. And you get left with 98. Then you have to divide that by 2. So that measure on the outside of that x is 49 degrees. All right, for these, what I would like you to do is to do all of them on your own. Number 1, number 2, and number 3. And the video is going to prompt you to enter your answers for 1, 2, and 3. So make sure you work these out, show all of your work, and then enter your answers.